買飛嗰啲成個演化，你點樣影響現有個買飛行嗰個嘅 system？ 咁 system 即係其實同 full stack 有啲拉拉，但係佢就再 hardcore 啲 server 嗰啲嘢。咁但係佢可能未必 system 嗰邊嗰啲人咧就未必會接觸到份嚟嘅，係啦。咁所以你就咁另外再下一層就真係客嘅人，搞客嘅人嗰啲就係咩咧？而家 IoT 啦，好多即係例如 STEM 而家好興嘅個玩咧呢個方面嘅機械啊，嗰扎係屬於客嘅人嘅係。咁因為你補翻少少 electronic 或者 mechanic 嚟咧，你其實搞。咁另外就係軟件啦，軟件都有分幾種嘅。咁軟件就係呢度講個軟件就係真係電腦上嘅商品，或者喺手機上嘅 app。咁因為佢哋個設計其實同你 server side 即係 back end 有 level 你 software 咧未必有 level 嘅。不過而家普遍都應該會有 level，因為如果唔係咧，你買唔到 subscription。因為而家盜版問題，所以全部都有開賣，係啦。咁另外一種就係 platform 就係 shopping cart 啊嗰類啊，好似淘寶嗰啲，咁其實都同啲大品牌都有啲關係。但係你去到做 platform 就係要熟嗰個 business flow 啦。你熟個 flow，你俾唔到少數，或者其實唔知道點樣去解決嗰個問題，或者 platform 亦都係譬如嗰啲貨運 logistics 咧，你都要熟個 platform 就係if 譬如郵局啲人寄投遞嗰陣時，啲嘢點樣去登記我啊，同埋其他人點樣去用同一個 API， 即係設計一啲 API 同公司去夾，咁呢啲屬於 platform。係啦，咁所以 last 最大用嗰 part 咧就係 game 啦 ，game 又係另一個世界嘅，上面嗰啲唔使理嘅 game 係另一個世界。咁當然啦，如果寫 online game、MMO 嗰啲，你就要熟 M。咁但係 game 咧係另一個世界，點解咧？因為 game 嘅好多使用嘅喺度，同我哋而家日常，我哋其實頭先上嗰啲主要係商用，或者係去做最多你 hardware 都係去到我哋更新嘅，但都係主要商。但係 game 咧係一個個人為主，同埋係即係。比較差嘅好多時做，但係 game 咧所需要用嘅技術咧，比上面嘅任何一樣嘢即係 game 其實係等於做緊專業，即係如果喺硬件，普通 software 嗰啲大型系統最多係用飛機嘅，但係 game 咧係可以去存在。咁當然睇你做咩 game 啦，你都做啲Candy Crush 啊嗰啲就嗰啲仔啦。咁但係即係你如果係真係做 3D game 嘅。做 MMO 嘅嗰個即係咁咧，再講下如果 skill 咩 skill 啦。咁其實而家我哋最多都係咩 VR 啊、AI 啊、Big Data 啊、security 啊、system infra 呢扎咩嘢啊？睇落好最新啊！呢度有幾多本科嘅？咁或者有幾多本科？即係講啲三層。Engineer 咧，係啦。咁即係 SE 啊嗰啲，即係 CUHK 啊嗰陣 mechanic 咁。哇！咁如果係冚差唔多啦，呢扎嘢全部你。Graphic image processing 交線 ，custom head 交聲 curve 係啦，你哋嗰啲 filter 啊嗰扎嘢 ，AR 其實全部用緊呢個 HTML。點樣認 pattern？ 點樣 find the picture 嘅時候？點樣 find the picture？ 全部呢個嚟喎。graphic 嘅 AR 其實就係呢個喎。好啦 ，3D 一定有學啦。咁當然啦 ，3D engine 係另一個世界啦。但係去到 3D 咧，正確嚟講都係嗰三個嘅。3D 最難嗰下係咩咧？係 texture 圖嗰 part image processing， 全部做嗰啲叫乜鬼啊咩AR 咩鬼表牌啦，其實表牌整完之後，整到膠磚好難睇嗰啲啦，佢哋全部要用 edge detection 嘅 algorithm。咁你唔識用嗰堆嘢咧，嗱學咗你唔知點用，嘥氣嘅，一定要知有用個程式界。你如果識咗呢個 image processing， 你只需教咗啲AR， 係啦 AI 就係好簡單啦 ，AI 就係講緊邏輯啦，邏輯其實佢哋主要而家佢哋相長相嘅 AI 同學院入面嘅 AI 係有分別嘅。學院入面嘅 AI 主要係叫 logic model， 個 logic 點樣令到佢可以即係我哋其實變翻個 model 之後，個 computer 識自己去咧。我哋要 define 嘅，如果唔係個 computer 唔識處理嘅。咁而家出現嘅坊間講緊嘅 API 咧，其實就係已經有個 model， 然後你教佢咧，兩樣嘢嚟嘅。嗰個其實我覺得似 big data， 因為佢個極地 tensor model 嗰啲已經唔需要你而家攞嘅 model。咁個 logic model 嗰樣嘢係用呢樣嘢，咁但係有冇需要？即係其實有冇需要得咧？個 logic model 就係 AI 車或者 AI 嗰啲自動導航系統，就係我哋嗰啲 A star 啊，嗰啲咩 Chi search 啊，嗰啲 A star search 啊，全部就係因為你就好快就快解，同埋喎你仲要有電子眼啊，電子眼就而家唔會錯嘅，即係即刻變成成場，知道嗰個人嗰架車，其他嘢唔緊要，就只係安全就得啦。但係你知呢個係呢架車。好啦，咁 data analysis 講緊 big data 啦 ，big data 就做緊咩嘅？用到咗 balance 主要係咩咧？第一就捉有冇寫，捉有冇做假數。股票買賣都其次啦，你淨係呢兩嘢寫到個科度做嘅。咁其實我數學科捉假數嘅，咁但係捉洗黑錢嗰樣嘢，我哋行得點樣咧？我就未聽到有嘅人即係如果有嘅可能之後大家講啦。咁但係即係如果做假數咧係有 error 嘅。咁你識嗰個 error 嘅，你自己做即係自己識點樣 bypass 嗰啲嘢去做假數咯。係啦，即係有啲咁嘅 knowledge 要知啦。咁另外即係 big data 再其實而家喺 FinTech 嚟講最重要嗰 part 就係講緊股，咁當然啦，有 big data 冇用嘅，你冇上面嗰啲 high model 去識，咁所以呢一度大家就可以諗諗點樣去推理。咁另外你last security level security 好重要啦，呢啲講之前俾人爆晒嗰個 security 啦。咁其實最主要嘅 security 嗰 part 就係加密化啦，同埋你可能一啲嘅 security app 啊。差唔多食奶㗎嘛，啲人唔介意㗎嘛，係啦。咁另外 system 同 infra 就係譬如你假設我要上面要做翻上面嗰啲嘢，我需要用乜機，要用乜嘢系統，要用乜嘢 software， 呢啲就係 system infra 要用咩啦？呢啲就係用咩嘢？咁再 more detail 啲就係 robotics。自動車，你架車要點樣做啊？制動系統點喐啊？其他嗰啲嘢，當你嗰個鏡頭電子眼，你點樣去 set， 令到佢可以即係令到佢嗰個啲數據入到去你嗰個車嗰度電腦，你嗰部電腦用乜啲電點樣搞？全部個 robotics 係聽擺細電，大電唔使識嘅，但係細電你都要識咯。好啦，咁繼續講呢條，好啦，再見啲做翻好本同 software 嘅層面啦。喺 software 嘅 skills 咧，即係其實啲人成日問嘅，我 coding 同咩 language 冇嘅，我教即係通常你是但揾一隻得㗎啦。但係當然啦，揾隻設計係好㗎啦。 咁設計係好嘅，其實 Python 嗰個係好嘅，我覺得 Java 好啲。咁但係啲人覺得 Java 好難寫，咁梗係難寫啦，因為佢嗰個即係佢其實好要做好多嘢啦，但係佢思路好多。即係我自己覺得 Java 好啲。咁另外其實如果去翻 C 都好簡單啲啦，C。如果 C 加加咧，其實我覺得係深得滯，用 Java 教咁最主要其實 software skill、programming language 係咪重要嘅嘢咧 ？programming language 你最緊要識得個 language。個 language 嘅 skill， 即係每隻 language 有個優點，有個缺點，你要知晒。做乜嘢嘅時候用邊隻，呢個先最。咁即係譬如有啲情況下用菠蘿嗰啲嘅，去寫普通嘢用菠蘿。即係譬如有啲嘢 R 會好啲嘅，咁但係 R 做晒所有嘢。Python 有個嘅好處嘅，咁但係去到某一啲情況係有 limitation 嘅，或者要知啲嘢，然後去揀一個最啱加非成全。呢個所以個 sense 好重要。咁另外就係 DB 啊 database 呢樣嘢啦 ，database 喺度咩時候啊、老時候啊，但係即係最重要一樣嘢就係，無論你點樣處理個 database 都好，最重要嗰 part 就係你要知道成個 IT 界、成個電腦世界、你成個系統最重要嗰 part，最重要嗰 part data。你冇 data，你就係個成飛咯。你個 data 變晒買嘢啦，即間公司破產，係啊，所以 data 好重要。data 就係啲點樣？除咗佢 access 嘅快之外，啲嘢要啱，同埋最重要係呢樣嘢。即係佢如果個 DB 賣唔緊要嘅，你可以揾啲地方裝住先咯，同埋走去慢慢做過嚟，係得㗎啦。即係呢啲就係你哋要諗數據。好啦，咁另外即係譬如有 FinTech 啦 ，FinTech 就 FinTech 個世界就非常之大，其實都係好市場。即係你熟咗行，你做過，你就有個知道嘅 process 嘅 process。咁咧基本上咧行啲嘢就錯得太多啦，同埋前面嗰年嘅實機能力啊嗰啲嘢全部知，全部有後機啊嗰啲嘢你就識得做。咁另外咧。即係你要熟就係真係好似有啲嘅標準，即係除咗咩 payment 啊、trading 啊之外，你可能仲要睇咩 CRM 嗰類嘅，你熟公司嘅運作，或者有一啲即係譬如大間公司都有類似嘅運作，你將佢啲運作翻嚟做一個 software， 慢慢去嚟。咁有好多譬如嗰間公司嘅 X， 間公司叫做網嘅，但係而家佢哋話發晒。咁 IBX 嗰間公司係啲大學到咧，嗰間就做緊呢個嘢，即係大家可以諗一諗有咩 business model 可以做，即係呢度都唔係淨係講大哥，有可能大家有啲自己嘅想自己開公司，咁自己開公司有另外一啲學校嘅，即係所有機會，有另外一啲好重要嘅，但係呢個之後可以做。咁但係即係你如果想自己開公司，想做自己嘅 product，呢啲更加。咁當然啦，即係後面最重要就係嗰幾 part 啦 ，attitude 啦，你嘅態度好重要嘅態度，知道世界揾食艱難，做係應該嘅，不過唔做得嚟有時你可以做下。咁但係即係最緊要知自己做乜，認真去做自己，做好自己嗰份嘢，嗱，咁啊呢個 attitude 啦，即係人哋講嘅，你就諗下先咯。諗下先，譬如啱聽嘅又唔使話嘅，啱聽即係之後會有壞處睇咯。即係有啲嘢唔使，即係有時候可以直識其非嘅，但係有啲長篇文嘅話唔做，即係有時即係好傷到自己。咁啊，另外真係有一樣嘢俾你培養啦，呢一條咧就係即係聽講啦，即係如果唔係好似我哋夾嗰啲10年9年嘅至少賴嘅最後一個時間。咁啊細，唔知點解佢哋仲收到錢？即係嗰啲，即係如果你考 U-Level 咧，其實冇話得嘅，啲嘢其實做大家數嚟做。咁但係即係 U-Level 咧，或者學生嘢咁，其實 就算你做幾耐都好，去到呢度。咁最重要即係你哋學嘅叫 problem solving 嘅 skill 啦，即係其實好簡單係點一齊諗，我覺得好簡單。你對嘅係講譬如，可能你原來係你望咁樣，你自己成呢個我自己有個咁嘅興趣啦，一見到人哋同我扭落，你呢個係唔寫嘅。咁你慢慢練下，你就識得點樣設計嘅方法。即係10啲嚟講，10啲人講法，即係你呢啲就真係講唔出。咁另外一樣嘢始終都係啦，一間公司做嘅一個人嘅係唔掂嘅，咁所以即係 teamwork 好重要，開放好重要。咁所以咧，即係大家喺度讀書嘅時候，做 group project 嘅時候，有冇嘢咧？定係俾晒人條友做咧？係啦，即係呢個諗法。即係呢啲 course 即係我成日都問，如果喺學校嘅 course 都要請人，或者去抄人嘅，咁你出到去呢個要諗一諗，比較嚴重嘅需要諗。咁基本上咧就而家係啦，有冇咩問題？都有，定係冇？定係驚咗之後太多。有咩問題嘅？想知或者有冇咩經驗，即係想我講故仔。創業啊，講兩句創業。講創業啊？你冇資本冇㗎？呢個係我哋開公司，我哋做 startup。做咗咁多年嘅結論，你冇錢冇，你揾唔到大水喉冇，真嘅，出面所有人都係呃你，你冇背景冇水喉，基本上你只會得個做，而係追唔到數。我哋啲10年啲人出嚟爭我哋賺到多錢，但佢哋啲人出晒街喎。你咁即係你寫啲嘢唔俾佢用，佢就告你都係得成事。所以呢一樣嘢，大家諗啦，即係我哋嘅 learning 就係你冇咁嘅能力，你可以冇資本，但係你把口要好叻，係真係氹到人講下幾多錢。就話即係比較錢比唔係比較細嘅喎，一定比較難。一個成功嘅可能，我可以講咗。蘋果 WWDC 就有個咩 HomeKit 啊 ，HomeKit 阿 David 係我老細嘅，即係我哋而家公司。佢個 project 你哋大家估成嚿嘢要幾錢？3球點解你講？人哋攞3球，3球點解你講？就係佢哋真係攞到有咁嘅idea，攞3球做出嚟上。好啦，同樣8件咁480萬，做嘅嘢一樣㗎，喺 spec 係一模一樣嘅嘢嚟㗎，只不過因為8件咁，啲人就覺得50萬。咁大家諗下，究竟係咩問題？出咗咩問題？究竟係你嘅輸送啦，你嘅輸送？你可以話有你嘅輸送，佢可能真係最後尾出嚟嘅波得係值4個萬嘅，但係佢最初寫嗰個框架，人哋公開應該攞嗰480萬寫完之後點啊？你確而家就攞嗰480萬揾空確班人，你個 N 字賣出嚟，係嘛？呢個最快你有啦嘛，仲申請咗4樣件事㗎，係咪？開始係啊，停㗎啦！而家問題時間㗎，即係可以散嘅。
我哋問到個問題咧，政府呢一排瘋狂咁地吹呢個發展 I.T. 啦，你覺得政府做唔做到嘢咧？
嗱，呢一樣嘢咧係個迷思嚟嘅。我其實之前已經想寫文㗎啦。人哋話乜你有做咩？你真係做唔做到係自己覺得做唔做到啊嘛，做好自己啊嘛。香港唔係冇機會㗎，有㗎，唔係政府講嗰啲。政府講嗰啲佢係你有個情況去你嘅選擇，但係唔緊要，照食咗先，食到有機會食係食啲先啦，係咪先啊？你都俾咗錢㗎啦，你交咗稅㗎啦，咁個問題我唔會反對。不過佢咁樣放支旗出嚟，我就覺得喺自由市場下邊，因為你嗱香港好多公司其實揾好多錢嘅。好多係換證物，尤其是 I T 好多換證物，係我哋去揾嗰啲公司就係話，嗰啲先知係其實賣緊歐洲賣緊美國好犀利嘅，但係個問題佢哋本身係好多嗰啲唔係新生咯，家族生意咯，佢上一代老豆啊嗰啲公司落嚟，佢要轉型，因為同個仔成日賣屌你。我而家我揸住話事，如果老嘢未死啦，而家老嘢死晒嗰啲就一間嘢我話事，我要生存，我就要存，嗰啲揾緊錢㗎，我睇出嚟。咁但係嗰啲唔會向政府拗水㗎嘛，冇需要㗎嘛，佢都做緊啊，我點解要拗啫？政府你知啊，政府嗰啲課程幾廿萬咁方便，仲要拗數呢樣嗰樣，你都政府錢嚟錢。你係佢嗰啲人就唔係啫，你唔係佢嗰啲人。一毫子都係，即係所以個問題就係政府嗰啲冇話幫人，你要知自己做緊乜，你要知自己幾十蚊先得嚟。香港700萬個市場唔細，你話細唔細話大唔大啊？但係你比歐洲啲國仔10幾萬，幾十萬。喂，你香港700萬人喎，你一個中國喺非洲嗰啲好多，咁點解你700萬嘅生意？嗰個人自己嚟，就唔好得意嘅，即係人哋搞你唔啱嘅，你嘅機會少咗嘅，即係殖民地而家都係殖民地啦，以前而家冇分別嘅。點解而家以前啲人揾到錢，而家揾到錢？心態真嘅，以為大陸有得靠，你靠黐咪死。以前英國都信唔過，我哋要靠自己嚟。你講翻啦，你要知自己做緊乜，呢個先係。你要知自己個 part 點標，你記得我做好我自己，首先做好自己先。咁呢個就我成日想寫個表達嗰個700萬嘅市場唔細，點解以前可以食晒全世界？移民潮係對香港好傷嘅。我諗點解移民潮嗰班其實好多㗎，啲人話好多人移民又唔得嘅。會有翻嚟嗰班計嘅，會推晒移民嗰啲，我識得好多做晒嗰啲大公司嘅高層。我喺英國嗰陣時識得有個佢以前教書嘅，最後尾而家係賣，英國都俾咗成間巴嘅。即係個問題就係勁嘅人走晒出嚟，好乸勁嘅。咁點解以前香港咁勁啊？都係移民嗰班走翻嚟。移民嗰班好勁嘅人喺晒度，但係因為97問題，而家你我哋個問題就係我哋係咪勁得過嗰班人？呢個要因為新人啊嘛，所以心態，即係我講到英國外國真係嗰個點人哋係嘅，你嘢諗定晒先做啫嘛，咁佢一做係流咗。喂，你唔係喎，呢啲我哋係咪都係唔死啊？有成年頭行咗先得，人哋講，咁你咪全地冇晒資源去錯，資源有限，要一擊即中，所以呢個就簡單。所以有陣時開沙漏，你如果打緊工嘅，繼續打到工咁上下啦，或者真係衰變咗有個大轉頭先做出。 你最緊要就係個財根好，冇咗個財根咧，即係香港好似第二個地方有食有酒，香港冇食有。我啲同學食咗幾年就睇到喺香港唔得㗎，即係咁，所以個情況就係要諗得好盡所有部署佢，其實啱嘅，因為我哋而家700萬對到個你同歐洲啲國仔，歐洲啲國仔佢搞啲國仔都幾難。我哋後面，我哋上面有13億，夾除咗個13億㗎，我哋兩邊13億。呢個就係咁，仲有咩嘢咧？因為一個思想教育嚟㗎嘛，呢個真係大家要認真諗一諗問題，因為真係越嚟越難生存。好得。
咁大家留意翻我哋依家個方法時間咧，會推遲到去到2點半嘅。咁就我哋2點半翻嚟之後咧，咁大概有10分鐘得閒啦，即係俾大家翻嚟嘅時候。咁就我哋會2點半到2點9開始下一個 session。咁有少少順延，咁就大家會麻煩請見啦。咁另外咧都提醒翻大家入會場嘅時候，即係 lecture hall 3或者5嘅時候咧，都麻煩帶翻個 badge， 我哋嘅工作人員都會認翻嘅。咁冇 badge 係入唔到場嘅，係好難係。咁樣咧我哋都有好多參觀者都問可以去邊度食飯啦。咁我哋其實咧後邊嗰個registration lobby 咧，即係大家攞 badge 嘅嗰個 lobby 咧，望出去咧，咁就已經有一個飯堂㗎啦。咁要一路直行少少啦。咁然之後咧泳池隔離咧亦都有個飯盒連樓嗰度亦都有個 canteen 啦。咁同埋百佳嗰度都係有嘢食嘅。咁如果大家都唔遠嘅話，咁可以落翻去火車站嗰度都有嘢食嘅。咁我哋喺2點92點半到2點9再見翻大家啦。多謝。 拜。
女 IT 狗啊，女嚟嘅好似。女 group 真係唔得。
OK， 好，歡迎大家翻嚟。咁好啦，我哋而家下一場咧就係由阿 Steph 講 GraphQL The Introduction to the Future 嘅。好。
Okay, so are we ready? Are we ready? So good afternoon, ladies and gentlemen. So I'm your speaker today in this session. So I will talk about GraphQL and how it could lead you to the future. Okay, so let's get started. So okay, so today, so this is our schedule today. Okay, so first we will talk about what is GraphQL. Okay, and we will talk about, I will introduce you to types, and then I will introduce you to schema, and we will talk about some of the standard operations, or we will talk about some of the standard operations, and first we will talk about query, mutation, and subscription. Okay, and we will also, I will also show you a very simple demo application. So it's just made very in a hurry. So yeah. So but I will also talk about some of the very challenging problems in GraphQL, and so how it could be easily succumb to attacks like recursions. And I will show you some reference so for you to reference in the future. And at the end, I will give some I will say thanks to the host, and if so, I will try to address your questions. Okay, so first let me introduce who I am. So I'm Steve. I'm Stephen. So hello. So but you could also call me Stefan, because my name forms my first characters in my name forms this acronym, forms this this thing. So just like you, I'm just an ordinary student like you who likes the latest tech. So recently I'm really into this the idea of GraphQL, and I'll always try to give you a introduction, and if possible a promotion of GraphQL. Just a small scale event, so nobody would know. And so this presentation would rather be some simple format, so we wouldn't show you some very sophisticated ideas, and it would just really just a tip of the iceberg. But yeah, so it wouldn't cover much. So I wouldn't show you some real codes that I encountered in the process, but and sometimes it could be seen as some informal constructs. Okay, so please try to make sure that this kind of knowledge may not be valid in the future. Okay, and I may miss some other important ideas, but I think it's good enough for you to get started in GraphQL. Okay, so before we start really talking about GraphQL, so we will have to. So we know that GraphQL is designed by Facebook, right? So it's a framework made by Facebook, and it has been internally tested and used from 2013. So it has been like 5 years to 6 years, I don't know. So GraphQL actually comes up in a pretty. It should have get into a pretty mature shape, but right now it's still being considered some new tech because, yeah. Okay, so what does it mean by GraphQL? So would you like to think about that? So I will give you a minute or two to think about what Graph and QL really is. So yeah. So what do you think about that? What does it mean by GraphQL? So you could really speak it out loud. Anyone? Wow, that's embarrassing. Okay, but we could split GraphQL into Graph and QL, right? So we know what QL is. It stands for So we know, because we know what SITCON, that stands for Structured Query Language. So you know GraphQL is a query language. But however, what does it mean by a graph? Okay, so I know some of you may know what graph means, like in computer science, but I want you to keep it short. Okay. So when you talk about graph, you may think about you draw some line chart, some function graph in mathematics. Okay. So maybe it involves some math concepts, right? And so say like you have a function graph, so you have an f of x to x to the power of 2, so you draw a parabola in a graph paper. So it's just like that. But since here we're talking about IT and computer, so does it mean that we will have to go deep into computer science? Oh, but so if you think deeper, so maybe it's something about graph theory, right? Oh my God, maybe it's something so difficult, so nobody could know. But no, you don't have to worry about that. You don't have to worry about that. You don't need to know these kind of esoteric knowledges. So neither have I did. Yeah, and you know, you just need to know two basic concepts of graph theory, and that is what we call it nodes or vertices. And we also need to know about what's an edge. So here I show you a graph. So you can see here the inscribed circles. So you can see this oval shape here. So it's pretty obvious, right? I'll show you that these connections between these two entities, or we call it nodes or vertices. So they are actually edges. So their connection are edges. So nodes can also mutually connect to each other. So it could also form a cell loop on itself. So these are what they call a graph. And so this is also pretty small, right? But this is also a graph that is we use. So this is a simple graph database graph. It's used. It represents the Star Wars API demo. So I captured it from a paper, but I forgot to mention it. But this is also a graph, but it has a pretty beautiful tree structure. So it doesn't have any loops, but so you can see here, and it really. So you reference a lot of data in GraphQL, and you could also form some really sophisticated stuff here. So you can see that we could have a lot of like connections, and even they will have to add up to each other. So we could also see that it's kind of you could have a lot of big loops here. You could have a lot of circuits, and yeah, basically GraphQL is all about how we connect these data and query them in a loop in a run. Okay. So now I will try to talk about types. So types are really important in GraphQL. So it forms a basis for your schema to validate all of your data. So unlike REST, that it doesn't really have any kind of validation. You just pass REST like in a form of SAML or JSON. Okay, so in GraphQL we have a type system, and you can think of the type system like in programming languages, but programming languages types are more higher level than what we have in GraphQL here. Okay, so types can also reference to each other, sometimes even in a mutual way. So just like the graph I've shown you, right? Alice, Bob, and Eve, and they are actually a multi-graph. That is actually a multi-graph. Okay, so And this is why we say that GraphQL has a graph structure and it exhibits graph properties. So yeah, and that is why that GraphQL is very expressive and also very powerful in a level that it could squeeze the performance of your server, of your API endpoint really well. So now I will also talk about some primitives and scalar types. But you know, when you think of primitive, you would think of something like integer, string, double, just some default types we know in computer languages. But you know, scalar reduces to one thing, one and only thing, and it cannot be reduced further. Okay, so but you know, a primitive is already single and irreducible in a sense that it's already out the box. So yeah, but here we're just trying to give some we aren't giving some formal definition of scalar and primitives here. So who cares? Okay. So now, but yeah, there are still some default scalars in GraphQL. I will walk you through that. So there are like 5 default types, or 5 default scalar, if I remember. Okay, so first, it's an integer. So it's a 32-bit signed integer. So yeah, it has a range of -2/31 to 2/31 -1. So that is this number. But in practice, this range isn't really mandated or validated because you know the reference implementation didn't even do so. And so it's possible that we could get an integer that's 64-bit, although it's defined as 32-bit in nature. Because you know, in JavaScript, we don't have the concept of integers and floating numbers. So we all just represent all numbers in a floating point, maybe like double precision. And so it's kind of like we don't want to like try to fix these ranges so that we could get a performance penalty. Okay. So now let's talk about float. But so when you talk about float, you may think about float and double in like Java, C# or C++. But here in GraphQL, a float is actually double precision, a double precision floating point number. Okay, so it's IEEE 754, and it has 8 bytes. It occupies 8 bytes. So unlike in programming languages where float is 4 bytes and 32-bit precision, and single precision. Okay. So wow, and it represents something like these number and these numbers. So they are actually they aren't intentionally made, you know. And yeah, let's go on. So yeah, we use these to represent. So what's the difference between float and integer? So you could also represent integer in float, but I hope you don't do so because floating point arithmetic is kind of messy, and you would it's a lot more complex. So you should better separate them. So and we will talk about string. So it is a sequence of Unicode characters. Okay, so it's a sequence of Unicode characters, and one of the things is that the width of such character is undefined. So you could possibly have like a UTF-16. You could also have UTF-8. Sometimes even UCS4. But most of the time, we would say that the string is stored in a UTF-8 format because you know JavaScript use it, Java use it, and yeah. So we use UTF-8 as an universal character storage. Oh wait, what the? Hang on, here. So okay, now you can see it. Okay, so we'll go on. Let's talk about Boolean. But But you know, Boolean is just yes or no, right? So we doesn't really have anything to talk about. So, but there is also one special type, special scalar type in GraphQL, and that is what it called ID. And yeah, but it's so special that it could represent any value, just like an any type, okay? Just like an any type, but it has one special constraint. That is, it has to represent a unique number. It has to represent something that has to be one and only one. So like so you should use it like use it on like an UUID, okay? Or we could use it for primary key or auto increment column in like MySQL. So we could use it to represent this kind of number. But one thing that many people forget about is that we could also use ID to store hashes. You could, so you know, really just, you know, hash is also unique and one and only, right? So we could also use ID to represent hashes. But one thing to keep about is that in GraphQL reference implementation, this ID type is actually stored as a string, so that maybe because the rationale behind it is because we want the data storage to be flexible. So however, that means you have to store your UUID in maybe a text format. You cannot store it in like in a buffer, in a 128-bit buffer. You cannot. So you cannot like you cannot have like cannot have number type. You always have to make sure that it's a string in your internal schema resolution. Okay, let's go on. So now we will talk about some types that will compose. Perhaps that it will reduce to many other types, or even to scalar, and back and forth. Okay, so we have non-nullable declaration here, or we call it non-nullable, a strong assertion. Okay, so by default, because we want to query the data we want in GraphQL, so all data there is nullable. So all the types are nullable. You get what you want based on that. So everything you have to check for non-nullability yourself. So you use an exclamation mark to the end and to the end of the type, so that you assert that this value here cannot be empty. It cannot be null. If it is null, so it will have a very big consequence. And so you could have like a non-nullable integer here. You could have a non-nullable Boolean, but you know, non-nullable Boolean is really, really useless because Boolean just represents a yes or no. It cannot represent something that unknown. Okay, it cannot represent something like unknown. But it's pretty weird that you have a Boolean that represents yes, no, and unknown, and there's no middle ground here. Okay, and just like what we did in TypeScript, but you know, in TypeScript we'll have to strongly assert a value, not a type, and you know, in sometimes we have, this is really handy. Okay, just want to talk about it. So as I said before, if this value is set to violate this non-nullable contract, it has a pretty big consequences. So the document, of course, is seen as invalid, so it cannot be used even if other fields in your query are valid and they are complete. But because of this contract is violated, the entire document has to be disposed. It cannot be used anymore. Okay, so it's pretty strong. It's a pretty strong assertion. Okay, now let's talk about list. So when we talk about list, you may think about something like 1, 2, 3, 4, 5, and continuously. And yeah, that's basically what we will have a sequential storage of the same data with the same type as a list, or we could call it an array, just like what we did with JSON array. Okay, so so also, you know, it's bound. So the type is bounded with square brackets. That is what you see like array SS. So hello, and so we use square bracket to represent a list. So just like this. So here we have left square bracket, string, right square bracket to represent a list of string. And we have here a left bracket, Boolean, exclamation mark, and right square bracket to represent an array of non-nullable Booleans. So, but do keep in mind that this type, in combination with like as I had demonstrated here, non-nullable assertion. So you can have like these kind of funny things like non-nullable list of non-nullable types. So you could also have non-nullable list of nullable types, however nullable types. Okay, and so when it comes, so for example here, you can see that we have a non-nullable list of non-nullable foo, and we also have here the second one, non-nullable array of however nullable foo. Okay, in the last example here, we have a nullable array of however non-nullable foo, and that means if you had an array, so the values inside, the full value inside, cannot be null, otherwise are seen as a bad document. Okay, so sometimes because they are a position relatively similar, so people could really get confused with that, and it could create some really subtle bugs in your schema definition. So you could run into some client-side bugs, so that your client may not so they may not know that this value it shouldn't be null, but it's null anyway. So your program just crashes. Okay, so now let's talk about object. So object is just a map of types. You have key, value, and your key is identifier, and your value is a type. That is very simple, right? So, but you have to know that your identifier has to be in these regex. So what it means is that you can have underscore here and case insensitive alphabets for the first character, and later on you could have underscore and case insensitive characters and alphabet and numeric ranges, and it could go on and such. So also this is a very classic example of regex for identifiers in textbooks. So each pair of this identifier type pair is a field. Okay, so your identifier resolves to another type. Okay, so it also represents another data. Okay, cool. So for example, we could have this here, my special field, and we separate it with a colon, and then we have a non-nullable list of non-nullable string. Okay, so it means that this array has to be here, and the string cannot be empty. And when you select your fields in a query, it's called selection set. Okay, so you select the data you want in a query, and just like so when we compare it to list, we'll say that it's similar to JSON array. So as such, we could also think about object as JSON objects. So it's so hang on. So it's also bounded with curly braces, and you also have some key value based data. Okay, so this is what object is all about. And now but in GraphQL we also have something called interface. So when you hear of interface, you may know about the interfaces in Java and in C#. Okay, so it's very similar to that. But there's one thing that limits its use. So interfaces they want you to implement these fields. They forces you to implement these fields. If you don't, you're violating the contract and such. So it's like non-nullable, but non-nullable for types. Okay, so your types can implement multiple interfaces. So however, you cannot extend your types in GraphQL, although it could be used. It is used in, however, schema stitching, but I won't talk about it here. And when you implement multiple interfaces, and its functionality is something. So, but in GraphQL, this functionality, this limitation is weaker than like what we see in programming languages. Because so one of the examples is that we don't have interface chain here. So your interface cannot implement other interfaces. So it has to be combined into one type. Yeah. So this is kind of a big problem. So if you want to see that, you could, if you had opened my presentation, you could also click on this link to see what's happening. So this issue is still open. This problem is still open and is debating in RFC. Okay. So now let's talk about enum. So in C and C++, Java, and C# we have enumeration. We have enumeration type. Okay. So yeah, it's also inspired by what we could do in programming languages. So it's enumeration type. Okay. So we use it to define a set of values and constant. That couldn't be something else. Okay. So we limit the range of the value that we could result in. Okay. And so please do not use any magic constant or any magic cookies, any magic numbers in REST like you would do in REST. Okay. So if your values are other than what is defined in enum, is invalid. Assignment is invalid. Okay. But in GraphQL we also have something called union, and when we talk about union, you may think of like an OR type, and OR. So you put types together, but only one of them could exist. So yeah, so it's basically like this. So you have many types, but only one of them could be active at the same time. Okay, but so that means it's actually the tag union and discriminated union in our programming languages. So for example, like in TypeScript, we have tag union. So in the syntax are quite similar in conjunction with GraphQL. Okay, so it's a very powerful type construction. It's so powerful that we use union to make choices and conditions on types and on queries, and even so. For example, we would use it in a format like this. So we ... We have triple dots here, and on a type, and then we also make some other selection sets based on that. Okay, and just like this. But it's actually, so with this selection in mind, we could actually deduce that it is the same thing as pattern matching. So that when you use programming, so when you use like Haskell, like ML, and we have pattern matchings on types. So in GraphQL with union, we are basically doing that. Okay. So for example, we have we'll have a redundant protein. So we have an integer or a string or Boolean type here. So we have a union. It's a union of these three types. So it has to exist here also. So and we could also put it in use with list. So you can see here. So you can see here we have a list of integer or string. That couldn't be nullable. That couldn't be nullable. Okay. So it's really handy to represent some complex types. You have to make some choices on your field, some choices on your selections. Okay, so it's really cool. So now we will talk about fragments. So fragment is a partial set of your type, a partial set of your object. Okay, it's a portion of that. Okay, so it's attached. So as I said, it has to attach onto a type. So for example, you have like fragment, full fragment, on full. You may think that the the last three thing here, the last three thing on full and curly braces, triple dots and right curly braces, they look like a union yes. You also spread your fragment onto other selection sets or even types. Okay. So you could also compose it on other fragments. However, your fragment cannot be recursive. So you cannot mutually reference to each other. So because not only that is semantically invalid, but also it could be used to prevent some recursion attack in GraphQL. So we have some basic usage. So we share our queries. So if we put our queries into fragments, so we could easily update them in the future. So it's really good. So for us, full stack engineers is really good. It's something really cool. So that we don't have to manage so many query codes, and we have to update that in a batch. We could make it in a hurry with the use of fragment. So we in a query we do it like this. So we spread our fragment into this query called full get, and we'll get all the values that is defined in full fragment as well in this query. But there's something. So there's some dangerous thing I've talked about. So that you have a recursion attack in GraphQL. So it cannot form any kind of self or mutual or cyclic references. So it's not like your normal object types that you could have mutual references and mutual cycle. You cannot have that. Okay, and what? Okay. So this is banned in this is banned by the GraphQL specification. As I said before, it's used to prevent some common attack against GraphQL endpoints. So when you have to do something similar, you have to repeat your fragments, repeat your types to a certain level that it has to be deterministic. So now let's talk about input. Okay. Now let's talk about input. So in GraphQL, you could try to put some additional parameters, arguments to a field or to a type, so that we could get some other things. We could use it to make so your server code could make some decisions. So so we limit our array, so limit our sets of array, our length of array. So we could also make sure that the order of our array is like ascending or descending. And so yeah, just look at it. So just look at it. It just looks like this. And here I also show you an enumeration. This is an enumeration but I didn't bother to show that as an example. So you have ascending or descending. So you have a limit. You can only get 10 results from the data source, and then you spread it into a fragment. But sometimes this kind of thing is really tedious to type, to design, and we usually just put them into one composable input, and that's why we have input here. That's why we want to centralize all these kind of redundant parameters into one type. So just like argument. So yeah, it's really easier to maintain all of your parameters and arguments. So it also keeps your types in sync. Okay. So think of it like fragments, but this is for parameters, and I have just already emphasized about that. And so we use it to compose many other parameters. Okay, so just like fragment. Okay, so but it should not contain any object types. So it should, you could do that, but I urge you to not do so, because types can be circular, but parameters, in parameters you cannot use cyclic things. You cannot use circular things. Okay, so you should use referential data to represent other types, such as ID, maybe some other scalars. Okay, so please use scalars as much as possible when you are designing an input. So now let's talk about directives. So, so if you have written enough TypeScript and JavaScript, you would know something about decorators. Although it is still in stage 2, maybe stage 3. It's still in stage 2 in TC39. So it works like a decorator. So used to attach some additional things onto a type, onto a query. Okay, or even parameters. So, but one example of such use of decorator is that we have a deprecation annotation. So yeah, and you could also think directive as annotations in Java or attributes in C#. Okay. And here in GraphQL, deprecation is implemented as a directive. Okay. So we use an add sign here, and then we put deprecated, and we have a reason parameter, okay, to tell the user that why this field is not used anymore. Okay, and let's go on. So here we use it to notify our user that this thing wouldn't be used. We're just repeating the same thing. Okay, so that's it. Okay, so and finally we would have some descriptions. So descriptions are like comments. So please put so you want to explain some types, please put that in a description. So, and it's decorated using string literal, or you could use triple quote, double quotes. So you use strings to put it onto your schema definition, and your server will know that and generate a schema that contains this description. So you use single quote for a single line description. If you want multi-line, you would use triple quotes. Okay, and then you put your description and your explanation there. Sure. Okay. So so if you really think about it, it's just the same thing in Python. So you have triple string, you have triple quotes, and then you could comment on methods and classes. Oh, what? Okay. Can't see now. Okay. So, but these kind of descriptions aren't really visible from Clang. This kind of description, you can't see that. Instead, it will have to be retrieved by your IDE tools, by language services, so that it could provide some formatting and linting for you, and it uses something called introspection. I will talk about later. Okay, so here is a list of summary of the things I have told you. Okay, so you can see here we have an input. So we have a type that implements an interface. We have inputs, so you can see that we also have non-nullable contract here. Non-nullable types, and we have some a description. So I don't know why it is in multi-line format, but anyway, it works. And we have some types. We have an enumeration. So here is the interface we implement, and although it is not actually a fragment, but this is basically what we should do in database design. We separate the names into like different fragments, different string fragments. Okay, so we have fragments here. We have some other things. Okay, so this is the summary of what types are in GraphQL, and when you think of that, it is not that really complicated, right? Okay, now we will talk about schema. So so in the summary, I deliberately missed 3 types. I wouldn't want to talk about it, so actually they are related to something in schema. Okay. So what do you mean by we will have to separate it into 2? Okay. So are they just somewhere came from somewhere. They just came out of nowhere. Okay. And so now we'll talk about root operations. So we have query. Okay, so you query something. You ask for something. Okay, then you have mutations. Okay, what the fuck? You have mutations. So mutations, you change something. You try to make something happen. So it's like a method. Okay. So but we also have something called subscription. So it is used as a data stream. Okay. So but actually, you can see that we define a schema like this. So we have a query, we have mutation and subscription. But if you do not give them, if you do not define them, these three will be the default types for your query, subscription, and for your root operations. And you can see that they are actually camel case, but that's not really just capitalized. Okay. So but you could also change this root operation schema to your like. Okay, so you could call it root query, you could call it root mutation, you could also call it root subscription, but by default we just use the capitalized name for each of these three query operation names. Okay. Okay, so I have just talked about introspection in the description section. So in description type we have mentioned this. So this is how you could get your type and your schema information dynamically. So from your endpoint, you could, okay. So you have something like double underscore type name. And we use that to deduce what data, what schema it is, what type it is. Okay, so it's almost the same thing as reflection in programming languages, but except that introspection has to be read-only, so you cannot change your metadata, you cannot change your schema data, okay, you cannot change the type data. So yeah, you can do that, unlike what you would see in reflection. Personally, I think that introspection is actually one of the elements of reflection. I said, although it is not a formal definition, right? This is not a formal definition of introspection and reflection, but in fact, they are two different things. So I have also shown you two table-ish graph, and one of them shows a very beautiful tree structure. And if in GraphQL, in GraphQL, you cannot really have this kind of beautiful structure. If you have it, please let me know. Oh my God, they are very optimized. Okay. So they are actually powered by GraphQL Voyagers, and GraphQL Voyager actually uses introspection to render such lovely graph. Okay, so you know they're so elegant, right? They look so good. They looked, but it's not flawless, however. So yeah, I think that this is a very good tool to represent your schema and types. Okay. So and now we will talk about CUHK. So maybe some of you know what CUHK is, but I will still show the meanings behind them. So for C it stands for create, right? And for R it stands for read. And for U, it stands for update, okay? And for D, it stands for deletion or delete, because we have to match the verb here. But actually, they are just some standard data operation, okay? So now let's talk about query, okay, finally. Okay, so in a schema, you have a lot of queries, but we will still we still have to separate queries into query mutation queries and subscription queries. So query actually correspond to read operation in CRUD. So CRUD is this is also get request in REST. So you get something from a query, you fetch something from the query and it's read only. It shouldn't do anything. It shouldn't do anything else, so that it has to be stateless. As a whole, the resolver has to be stateless. The function has to be stateless, and it shouldn't produce any other side effect. Okay, if it produces side effect, you have to make it a mutation. Okay, because so under these two assumptions, we have to say that this function, the resolver has to be pure, and by that, so that it is highly parallelizable. So we could make many queries on the fly. Okay, we could have a lot of queries in just one batch. Okay, and also one additional thing is that it is cacheable. It should be cacheable. Okay, so that so if you read some paper that's called semantic and complexity analysis of GraphQL, so that and if you use queries only, then this query language is actually NL complete. Actually, I don't know about what is NL complete anyway. I haven't learned much about complexity, but it just basically says that this problem is non-deterministic, so it could have many values, even if it is called. But you have to. So maybe it's kind of a contradictory. Oh, what? Oh. So it should be. So yeah, SITCON is NL complete. Okay. So, we have a very limited time here, so we have to go on. So mutation is something like this. So it actually represents create, update, and delete. So, but it also do all the rest, all the post, put, patch, and delete requests in one. Okay. So we use mutation to change data, to mutate them, to change states. So it could have some side effects. So that's why we call it mutation. And because of that, we have to make sure that mutations have to be executed one by one. It has to be serial, has to be in serial. Okay, so you could see it as an inversion of query. And one thing is that we push event into the subscription queue that is implemented in a PubSub pattern. Okay. So now we will talk about subscription. That just like what I talked about in mutation. So it's stateful. Okay. It has to be stateful because it's a frequent and reliable transportation of data from your server to your client. Okay. So it has a context. It has to have a context. So other client cannot relate to this subscription. So it's one by one. It has to be. So it's a real. It gives you a real-time data stream. Okay. And and if you some of you may have written some codes for Socket.io, but yeah. So subscription is something like this. However, subscription is a lot less powerful. Because in theory, this kind of data stream has to be one-way, so it could only emit from client to server to client. Okay. So but your operation can be parallel, so you could still do some mutations in some other cases, in other scenarios, so that you could basically still have a pseudo mutation, have pseudo bidirectional stream. Okay. So, but right now it's implemented as a PubSub pattern. Okay, thanks to GraphQL subscription. But but here, this GraphQL subscription module is implemented using assign iterator. That is one of the future things in ECMA script that will be JavaScript eventually. So man, so cool, man. But there is still some problems ahead. Okay, so this assign iterator still have some problems. So people are still debating that whether we should use assign iterator or observer pattern. Because in assign iterator you cannot stop effectively stop your event queue, so that it has some memory leak, and people really come into this problem. I haven't personally. So now we have some simple application, but I think we will have to skip it. I will have to skip it for time being, but I prepared it for you, but I think it's useless now. But if you have your phone, your computer, please take it out and enter this link. Enter the link enter the URL and put GraphQL after that. Okay, so you should have. So you will see a playground. You will see a playground. Please go to this link. Okay, so you could try. You could really try about GraphQL and try to see how it works in action. Okay, so maybe I could have. So I could query all the books. So you can see that it's linked. Is all. So you could design your query in a much standard and structured ways. So you could maybe something like this. So yeah, and we will show you its name. So you see we got all the data. So we use it to make a query. So it gives something like that. But I wanted to give you a demo, but because of some technical issues, we cannot do that. Okay. So I'll have to go on. 5 minutes left. Okay, sorry. Oh my God. Oh, now I will talk about some problems of GraphQL. Okay, so it has a very big time complexity. So so for time being, I have to show you all the points I would make. I don't know. It takes. I don't know. I practice a lot, but I'm still bad at timing. So you can see that because in REST you return a constant shape of data, so you do not have to make decisions. But in GraphQL you have to, and so that your queries cannot be optimized. So cannot be optimized by your JIT engine, by your programming language, by your virtual machine. So it has to be determined on the fly. Okay, so it cannot be optimized. Okay, so if you use some asynchronous programming, so you could also know that it really kills your memory, because you don't know whether this object is referred by other like thread and other processes. So we cannot. So unless all of us release all these objects, we cannot collect them. Okay, so it creates a lot of memory pressure. Okay, so because our resolvers have a recursive structure, so we are actually doing a depth first search. Okay, so on a type graph, so we do a recursion search. Okay, so it's in general a very expensive operation. Oh my God. So yeah, sometimes GraphQL can be less efficient than REST in terms of core performance. Okay. So you see that we also have some infinite fragment attack. But although it is explicitly banned by the GraphQL spec, but yeah, so this thing cannot happen. This thing cannot happen. But this here, if you see that it actually repeats these two patterns again and again to an infinity. But yes, this query is valid, and it is a problem. It could create a lot of resource waste in your server, in your endpoint. So people could really abuse this. So we have a lot of recursions. Okay, so it could be very CPU intensive. But worst, because it eats all of your server, all of your CPU stack, it eats all of your core stack. So it could crash your program, crash your server. So that's one of the reasons that people aren't encouraged in GraphQL, because they fear these kind of potential attack. And worse yet, it is not addressed by any official solutions. Okay, I'll skip it. sorry. Okay, so you can see that here, you can see that the data, if you put more depths, and the response time will go up exponentially. So this is also an example I take from a paper. Okay, but so finally, if you use one image to describe GraphQL with great processing power, it comes with great responsibility. So please use it with care. Okay, and now here are the references I read to make this presentation. So it's kind of ghetto, and I read these 5 references. So the first thing here is a blog post, and second here is a post from Facebook. Okay, this is the paper I used, and actually has many other papers, but I decided to delete most of them. And this one here is the GraphQL specification, and the final one here is the Apollo JavaScript implementation of GraphQL client, and it has server, right? So finally, I will have to say thank you to SITCON HK. So thank you for giving me a chance to give such a simple presentation. So finally, we have come to an end. And it's made using JavaScript. Actually, it doesn't use any PowerPoint and things and such. So if you end here, do you have any questions you want me to try to address? Do you have any questions? No? Don't worry, man. Just ask some questions. Okay, here.
When do you suggest to use GraphQL over standard RESTful API?
Well, first, how do you make? So in REST, one of the problems is that you have to make a lot of round trips if you have some graph structured data. So if you use GraphQL, it could be solved with a breeze. But in REST, you have to make a lot of round trips again and again. So that it makes a lot of wasteful bandwidth. So you have to make a lot of GET requests, maybe post, and all of the things in REST has to be referential. You cannot have any circular structure in REST. But although you could use OpenAPI to try to make sure that you didn't mess up your data reference. So in comparison, REST is a lot less powerful than GraphQL. But if you have some simple usage, so you have some simple APIs, you could just use REST as normal. But unless you are trying to do some complex things, so if you want to express your conceptual data, your conceptual schema more, so you should use GraphQL. If you want your existing client to use your API, you should use REST. So this is because GraphQL still have some big problem because the query language is formally defined. It has a very strict structure, so it has to be parsed with tools like GNU Bison and Flex or ANTLR. So, but on the other hand, REST has a rather simple architecture. You just use GET request, your POST request, and your HTTP methods. So you could just embed it with any kind of HTTP server, but in GraphQL it's impossible. So sometimes GraphQL is not a universal solution to this kind of problem. So sometimes REST has to still be used. So you cannot use GraphQL in MCUs. You cannot use it on an embedded system. But you could use an HTTP server in an embedded environment, right? So you could do REST, even do REST in these kind of environment. But you can never do that in some tiny things. So GraphQL still has to be used. Oh, sorry. Did I just elaborate too much? Oh, sorry, man. So because time is really up, Okay, just bear with it. Okay, I made up. So this is the end of my presentation, really the end. So I have to give the venue to the next speaker. Okay, here. So
喂，聽唔聽到啊？聽唔聽到？睇下先啊。好。睇下先啊。我解釋下今日個程度先，因為係如果你已經好熟 Git，你已經用開 Git 嘅 command，今日會悶親你嘅。係啊，咁今日係純粹係一啲你係知少少咩係 Git，或者你係聽過 Git 呢個名，你想學，或者係你純粹係想知道乜嘢叫 source code control 咁樣嘅程度，就即係可以啱坐喺度啦。如果唔係就希望就唔好悶親你。咁咧第一件事係有冇人有帶電腦嚟想落手做㗎？因為有嘅。呢度有幾條 link 嘅，有興趣 download 咗先，係啦。咁如果唔係你就跟唔到嘅其實。咁解釋下啦，有3個 software 嚟嘅，呢度 suppose 係唔係2個 software 啦嚇，一個 software 係最頂嗰個叫 Git 嘅，係啊。咁我哋今日會係一個 command line 為主嘅一個 present， 係因為GUI 咧去到唔同 platform 係完全唔同樣嘅。我上次做 source code 咧 ，source tree 啊，喺 Mac 機同喺 Windows 都係唔同樣嘅，所以教唔到咁樣。係啊，所以就最基本就係用 command 嘅其實。咁另外第二個就係如果你冇一個用開你自己一個打 source code 嘅一個 editor， 我就會建議你可以裝個 VS Code 嘅。係咁如果你有用開就其實係唔使裝嘅，都係 optional 嘅啫。第三就係如果有時間，我一陣間可能試下即係喺 GitLab 度做啲嘢嘅，咁就大家可以喺 GitLab 度攞個 account 嚟玩，係啦 ，GitLab.com 啦，係啦。好，有冇人睇完係未做晒 link， 即係抄晒落去先？呢個得未㗎？因為得就繼續落，因為我驚我overrun啊。